All right, so again, chapter 1, section 2 is linear equations with one variable. We start with literally like some reminders about how to solve just a linear equation. So the goal is to isolate the variable. There are two special cases when you're dealing with equations. The first is if the left and the right sides of the equation, of the equal sign are equal, then the answer is all real numbers. And that could be at any stage of solving it. So that could be at the beginning if it said 2x plus 10 equals 2x plus 10. That is all real numbers. It could be after we subtract 10 from both sides and you get 2x equals 2x. That's all real numbers. It could be after we divide 2 on both sides and x equals x. That is all real numbers. And it could be after we subtract x from both sides and I get 0 equals 0. That is all real numbers, okay? And it doesn't have to be 0. It could be 2 equals 2. It could be 3 equals 3. Anytime you've got the left side and the right side to be equal, that would be all real numbers. The second, so again, all real numbers, first case. The second is if the variables cancel out and what's left is a false statement. So for this one, you would wait until after the variables have canceled out, and if they have, and what's left is something like 2 equals 3, that's obviously not true, or 0 equals 4, that's not true. That would be a no solution question. There is no value for that variable that you could plug in that would make this equation balanced. Other than that, you're going to solve them, and you can get whole numbers, and you can get fractions, and you can get negative numbers, and you can get decimals, you can get all different kinds of numbers. But as long as you can solve it and it's not one of those cases, you'll get to your answer. At this point, you should only have one answer. Like eventually when we get to quadratic, you can have more than one answer, but for right now, you can have just one answer. All right, so we practice. Do all these. All right, so this whole first slide has, like, there's no parentheses or distributive or fractions or anything. These are just, like, your basic equations. It starts off in the beginning with just one variable on one side, and then it gets into, like, two variables, but it's the same variable. So number one, our goal would, again, to be to isolate that x. I can add 6 to both sides, and I get 3x equals 6, and then divide both sides by 3, and I get x equals 2. Same process for 2, isolate the x. This time, and you can do this in whatever order you want, but you could subtract the 3x from both sides, and I get 2x plus 4 equals negative 8. And then I can add the 8 to both sides. Subtract the 4 from both sides, and I'd get 2x equals negative 12. And then I can divide both sides by negative 2, or by positive 2, and get negative 6. You could have also, like, added the 8, subtracted the 5. Like, whatever you do there, you can go, it's whatever order you really want to do because it's all addition and subtraction. For 3, I'm going to subtract the 7. Negative x would equal 12. And then I would divide or multiply by negative 1, and I get x equals negative 12. Questions so far? All right, 4, we're going to subtract the 2. 7x would equal 21, and then divide both sides by 7, and x equals 3. 5 is the first one that has 2 variables on it, but they are the same variable, okay, which they will be throughout this section. So I'm going to add the 2x. I get 7x plus 3 equals 6. I'm going to subtract the 3. 7x equals 3. I'm going to divide by 7, and x equals 3/7. You want to leave it, as 3/7. You don't want to put that in fraction form, in decimal form, okay? That would be a rounded number. So unless it literally said round your answer to something digits, then you always leave it as a fraction. It could be improper or it could be in mixed number form, but you just want to make sure it's simplified. All right, and then the last one here, I could subtract the 7, and I get negative 2x equals 8, and then divide both sides by negative 2, and x equals negative 4. Raise your hand if you got them all right. Okay, all right, good. Questions? All right, continuing on. Yeah. So 7 is the same. I would subtract 5x from both sides. I get 2x minus 9 equals 7. Add the 9 to both sides. 2x equals 16. And then divide the 2. And I get x equals 8. When we get to 8 and 9, now you've got parentheses. So you want to do what with those numbers on the front of the parentheses? Good. We're going to distribute into the parentheses. So for the 6, it's going to go at 6x. 6 times negative 1 minus 6 plus 4 equals, distribute the 3. 3 times 7x is 21x. 3 times positive 1, positive 3. I want to combine the like terms on the left-hand side before I move anything from right to left. So I'm going to go 6x minus 2 equals 21x plus 3. Now I can subtract the 6x. Negative 2 equals 15 plus 3. Subtract the 3. 15x equals negative 5. Divide both sides by 15. And negative 15 over 5 becomes negative 1/3. We always want to simplify at the end, but obviously you can still leave that in fraction form. Still good? All right, go to 9. Distribute again. 4x plus 8 minus 12 equals 5x minus 30. Combine your like terms on this side. So 4x minus 4 equals 5x minus 30. Subtract that 4x from both sides. Add the 30. X equals 26. Now the good news is on every single one of these answers can be plugged back into check. So if you're taking a quiz or your test and you have a couple extra minutes at the end, every single one of these can be checked by plugging that value back in for everywhere there is an X. All right, so on 10, you want to, distribute that 3 in. I get 6x minus 12 equals 7, and then be careful, make sure both of the variable and the numeric value after the minus gets that minus for the second one. So it'd be minus x minus 5. Then I'm going to combine my like terms on the right, so 6x minus 12 would equal 2 minus x. I can add the 12, and I get 6x equals 14 minus x. I can add the x. 7x equals 14, and then divide both sides by 7, and x is 2. $11, you want to distribute 2, so I'm going to distribute this. Negative 8x, positive 4 equals 6 minus, this minus goes to both, 2x plus 4. And that step right there, that last step is probably the most commonly made mistake on these is forgetting to distribute that negative to both terms, so just be really careful. Combine my like terms on the right, so negative 8x plus 4 would equal 10 minus 2x. Subtract the 4. Negative 8x equals 6 minus 2x. Add the 2x. Negative 6x equals 6. Divide by negative 6. And x equals negative 1. So again, it doesn't matter if you move the constants first or the variables first, as long as within the sides you're combining your like terms before you do any of those moves. Questions so far? All right, you are going to see equations that have fractions and decimals in them, okay? With the fractions, you can get rid of them. You have two choices really here. With 12, I could distribute the 1/5 in to both of these, and I'd get 2/5 x plus 1/5 times 5 is just 1. So you could continue to work like that. Or you can get rid of the fractions by multiplying by the least common denominator, like we just did in this last chapter, the The difference this time is that it's an equal sign. So when we multiply, we're going to multiply the same thing on both sides, and they are going to cancel out. So what do 5 and 3 both go into? 15. So I'm going to multiply the left and the right side of this equation by 15. Now on the left, the 5 goes into 15 3 times. So I'm going to multiply the 3 times 1, which means I'm just distributing 3 in here. If there was something other than a 1 in the numerator, I would multiply that by 3 first and then distribute it. So I get 3 times 2x, which is 6x, and 3 times 5, which is 15. On the right-hand side, 3 goes into 15 5 times, and I'd multiply the 5 times both of these. So 5 times x, which is 5x, and 5 times 2, which is 10. Then I'm going to subtract the 10 from both sides. I'd get 6x plus 5 equals 5x. I'm going to subtract the 6x from both sides. 5 equals negative x. And then divide or multiply by negative 1, so I get x equals negative 5. So here's a common mistake you don't want to do, is multiply what's in here by the 15. If there are parentheses and you are changing what it's being multiplied by, so there's something that's going to get distributed in on those parentheses, and you change that using what you're multiplying by, the least common denominator, then that carries through into the parentheses. You don't multiply, when you multiply everything by something, you don't multiply it in on the parentheses. Anything inside the parentheses would be not, you don't multiply it. It's like protected, and you don't multiply it by what you're multiplying the rest of it by. Questions on that one? And again, you can always plug that back in to check. All right, you do 13, and then I'll do 13, and then I'll pick back up with. All right, so what are you going to multiply everything by in 13? 12, good. I would see what 3, 2, 4, and 3 all go into, and that's 12. So I'm going to multiply it times this fraction. I'm going to multiply it times this fraction. I'm going to multiply it times this fraction, and I'm going to multiply it times that. So however many terms are in there separated out by that plus or minus, you want to multiply whatever it is by those. So the 3 is going to go into the 12 4 times. I'm going to come back and multiply that out, but it would be 4 times 2x plus 4. Then I get the plus from the sign in between, so be careful with your signs. And 2 goes into 12 6 times. I get 1 times 6, or 6x. Equals 4 goes into 12 3 times. I get 1x times 3, or 3x. And minus comes from in between. 3 goes into 12 4 times, and I get 7 times 4, which is 28. Now I'm going to distribute the 4 here. I get 8x plus 16 plus 6x equals 3x minus 28. I want to combine the like terms on the left first. This is 14x plus 16 equals 3x minus 28. Then I'm going to subtract the 3. 11x plus 16 equals negative 28. Subtract the 16. 11x equals negative 44. Divide both sides by 11. And x equals negative 4. And again, I can plug that in to check if I have extra time. Like obviously I wouldn't stop and do every question while you're going if you're taking a quiz or a test so that you can't finish. But when you get to the end, if you have the time, you need to check. Okay, so 14 actually has a combination of fractions and decimals, right? So if it was just decimals, because I don't think there is an example. Let me double check. There's no example with just decimals. But if there was decimals, let's say it said 0.02x plus 4 equals 10.5, right? And I wanted to get rid of my decimals, then you're going to multiply by powers of 10. However many digits there are that you need to move the decimal past, that's how many zeros you're going to give it. So on this side, there are 2 zeros. On this side, 2 digits. And on the right side, there's only 1. You want to multiply by the biggest one. So I need to move this twice, which means I'm going to multiply it times 100. And that would move my decimal 2 places to the right each time. So 2 places, and this is 2x. 2 places, and this is 400. 2 places, and this is 1,050. So if it was only decimals, I would do it that way. Multiply by a power of 10 to get rid of them. If there's just 1 digit after, I'm multiplying by 10. 2 digits after, 2. That would be 2 zeros, so 100. 3 digits after, it would be 1,000, okay? But that gets rid of them. Now 14 has the combination of both. So what I would say to do is look and see if it's easy to change either the decimal into a fraction or the fraction into a decimal. So if I look at 2/3, that's a repeated decimal. I can't rewrite that because it wouldn't terminate. But what is 0.25? 1/4. So I can change this to 2/3 x plus 1/4 x equals x plus 2. Now I would multiply everything by what? What do 3 and 4 both go into? 12. So this one's going to get the 12. 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 All 4 of those terms gets 12 multiplied. So 3 goes into 12 4 times. 4 times 2 times x would be 8x. Plus comes from this sign. 4 goes into 12 3 times. 3 times 1 times x is 3x. 12 times x. And 2 times 12. I'm going to combine my like terms on the left side. 11x equals 12x plus 24. Subtract that 12x. Negative x equals 24. Multiply or divide by -1, and x is equal to negative 24. Questions on that one? Okay, look at 15. Yeah.
So you can't solve it if it's like decimals and fractions?
I mean, you can. You just have to do it twice. Like, I could get rid of the fraction by multiplying by 3. And then if I want to get rid of the decimal, I'd have to multiply by a power of 10 to get rid of the decimal. I think it's easier, especially if it's a decimal that's convertible like that. If it was 0.25 or 0.5 or something like that, where it's kind of easy to convert it, I would do that. All right, when you look at 15, there's like brackets and parentheses going on, so you got to be really careful with these, okay? So I would start with the innermost parentheses and that distributing this minus to those. So I'm going to rewrite the 4 stays on the front. It would be 2x minus 3 plus x, because that negative goes to both, plus 5 inside the brackets equals negative 7x minus 2. Then I'm going to combine my like terms inside the brackets. So 4 bracket 2x plus x is 3x. And negative 3 and positive 5 is positive 2. Equals negative 7x minus 2. Now brackets work the same as parentheses. So I distribute the 4 in this time. And I get 12x plus 8 equals negative 7x minus 2. I would add the 7x. 19x plus 8 equals negative 2. Subtract the 8. 19x equals negative 10. Divide by 19. And x equals negative 10 over 19. Sometimes your answers are going to be weird. It's okay. Okay. Again, leave them as fractions. Don't try to convert that into a decimal unless it said something about answer, by rounding to the nearest something. Still good? No. Okay, let's do 16 and 19. Actually, I think it's 16 and 19, and we'll save 18 and 17. So 16 and 19. All right, so 16, I'm going to start by distributing that negative 2 in to the parentheses on the left-hand side. Again, be careful with your signs because it's negative. So it's negative 2x minus 8 plus 3x equals x minus 5. On the left-hand side, I'm going to combine my like terms. Negative 2x plus 3x would be x. Minus 8 equals minus 8. If you catch it now, you're done. If you don't catch it, because it's the same thing on either side of the equal sign, then I'm going to keep going. So if I add the 8 and I add the 8, they cancel. And I get x equals x. And you can catch it from there. If I were to subtract the x from both sides, I end up with 0 equals 0. And hopefully you catch it there. This is all real numbers because it's a true statement. And the left side equals the right side. On WebAssign, it'll say it in the instructions, but it says to put the word reals. All capital letters, okay, and plural. So if you get an all real numbers answer, you literally answer it that way. If you are doing this on a quiz or a test, you could literally do all real numbers. You could do reals. You could do ARN for all real numbers, okay? Or sometimes you'll see like a fancy R like that, which means the same thing. Any of those work on an open-ended question on a quiz. But on WebAssign, it wants you to put reals. Questions on that one? All right, 17, again, you're going to distribute the 3 to both. So 9x minus 3 equals 9x plus 7. I'm going to subtract the 9x from both sides, and I end up with negative 3 equals 7. Does negative 3 equal 7? No, and the variables are gone. So at this point, this would be a no solution. On WebAssign, it's DNE for does not exist. Okay, again, WebAssign wants it like that. DNE does not exist, all capital letters. You could put no solution, you could put NS, you could put NRS, which is really no real solution because that's sometimes an answer. When we get to imaginary numbers, things are different, okay? But any of those work for open-ended. Just realize that on WebAssign it wants that DNE. Questions for me? Yeah.
I did plus 3 and then added it to the 7.
So you get 0 equals 10, right?
Oh.
It's still not true. It doesn't matter as long as the variables cancel out and what's left is false. So it doesn't matter what you get there as long as it's wrong. Yeah, still the same answer. All right, so again, we'll save those last two.